So, good morning, sir. This is Group 1, and my group members are Gabriel, Lee, Yishan, and I. Our main topic for today is pre-stressing. Now, I will explain what pre-stressed concrete is. Pre-stressed concrete is a form of concrete in which internal stresses are introduced before its application so that it can counteract the tensile stresses produced in concrete due to the external load. So in case of big concrete construction projects like bridges, steel reinforcement is not sufficient to provide the necessary tensile strength. So in this case, prestressed concrete is being used. So prestressed concrete can be used for the construction of roof, floors, and walls, and also bridges with longer unsupported span. For example, Walnut Land Bridge is the first major prestressed concrete in US. Each of the post-tension concrete beams was cast at the bridge site in a single piece. After the concrete hardened and cooled, the cable was extended end-to-end through a design opening. A jacking device applied tension to the cable, which was then fixed in place. So next. So here is the principle by Gustav McNeill. When a row of books pressed tightly together end to end, it becomes a beam capable of supporting more books, which same goes to the prestressed concrete. So a proper engineered prestressed concrete beam can span longer distance than a reinforced concrete beam. Furthermore, it uses less concrete without cracking or breaking. This has a dual benefit of reducing the use of raw material and reducing the number of vehicle movements to transport the materials. That is all from my part.
Pretension is a technique in which we are imparting tensions in trench before stressing the concrete. Besides, most pretension concrete elements are prefabricated in a factory and must be transported to the construction site, so it will limit their size. And it is most used for the fabrication of structural beams, floor slab, hollow core planks, balconies, lintels, driven piles, water tank, and concrete piles. Next, this part will show how does the pretension apply to a concrete structure. For the first step, the bed preparing is required. Next, you can place pre-stressing wire, which is the rebar. Then put the nut by using hydraulic jack and to pull 80% of the strength of the steel to prevent the pull to be returned. Next, you can cast the concrete and it to take 8 to 20 hours to develop required strength between the steel and concrete after casting. After that, unload after concrete has hardened to require strength. Lastly, it will be transporting to the store.
Now I'm going to share to you the info about post-tensioning. So what is post-tensioning? Post-tensioning is one of the techniques for reinforcing concrete. And unlike another technique for reinforcing concrete, which is pre-tensioning, in post-tensioning, the tendons are tensioned after the concrete has been cast and hardened. This means that the post-tensioning is performed on the job site in cast-in-place applications. Besides, the pre-stressing force in post-tensioning will be primarily transferred to the concrete through the end of anchorages. Next, let me introduce the several components that use in post-tensioning technique. The first one is tendons. Tendons are the basic element that use in post-tensioning systems. It is made up of several groups of pre-stressing steel. Basically, the strength used for post-tensioning tendons are comprised of 7 wires low reaction steel, and the most common diameter of the tendons are 0.5 inches and 0.6 inches. For the pre-stressing steel, protective coating is assisting to provide high strength to the steel. In post-tensioning technique, the tendons will be placed inside the ducts and inserted into the formwork before the concrete pour. Second component of post-tensioning techniques is ducts. Pre-stressing ducts is one of the vital elements in pre-stressing system. The function of the ducts is post-tensioning system is to create cavity or void between the concrete and pre-stressing cable. Therefore, the cable can be tensioned and stretched after the concrete around it gets hardened. Besides, protection against the corrosion to the pre-stressing steel can be also provided by the ducts. There are two main types of ducts are used for post-tensioning techniques, which are metallic ducts and non-metallic ducts. Non-metallic ducts are also known as plastic ducts. For metallic ducts that made from steel strips with corrugation are commonly used for bonded post-tensioning tendons, whereas plastic ducts in the form of smooth pipes are commonly used for the application of unbounded cables, such as external pre-stressing and ground anchors. Recently, HDPE ducts have become commonly used for the application of post-tension tendons. Even though it is polythene, features over metallic ducts such as corrosion protection of tendons, reducing of friction losses during stressing of tendons are provided. Therefore, this becomes the main reason why HDPE ducts are becoming popular nowadays. Next, let's look at anchorage. Anchorage is the component that used in post-tensioning techniques to anchor in the concrete. Transferring the stress force through the tendons to the concrete is the main function of anchoring. Next slide. Now I'd like to talk about how does post-tensioning apply to a concrete structure. Firstly, the post-tensioning tendons, which are pre-stressing steel cables inside plastic or steel ducts, are positioned in the forms before the concrete is placed. The reason why the ducts are needed is to prevent the contact between tendons and concrete. If there is no ducts, the tendons will be difficult to be tensioned as the concrete around it has become hardened. After that, once the concrete has been poured, hardened, and gained enough strength, the cables are pulled and tensioned until the proper tensioning force reaches the tendon. In the process of tensioning, the steel will expand and the concrete will shrink. Operation of tensioning the tendons will be done by hydraulic jack. Next, one end of the stretched tendons will be anchored against the outer edges of the concrete by using wedges and barrels, whereas the other end is kept open in the duct. This will keep the concrete in compression and the steel in tension. Extra protruding post-tension cable is cut in concrete slab. Lastly, the concrete will be grouted inside the duct through a grout tube to fill up the remaining hole between the ducts and tendons. That's all from my part.
Okay, so moving on to the 5 advantages of pre-stressing a concrete beam. So the use of the pre-stress technique in a concrete gives it greater strength by providing an internal compression force, which counteracts the traction force produced by the loads of the structural elements. Next is the durability of the construction. One of the great benefits of the pre-stressed beam is the elimination of cracks from all the load stage. This absence of cracking supports the structure's greater capacity to withstand loads, impacts, vibration, and knocks, while minimizing the possibility of corrosion in the steel, thus increasing the durability of the construction. Besides, the use of the tensile concrete allows for large spans in construction due to the length of the pieces, which providing saving material and greater lightness. We find an example of this in the use of tensile pre-stressed beams for enclosing large space, such as industrial warehouse, while providing greater luminosity in covers for car parks. For example, the use of concrete plates allow greater separation between the loading columns and therefore better use of the space and considerable saving material. Thanks to technology nowadays, the serial production of pre-stressed beams and hollow core slabs giving solution to all of the phases of the process allow greater quality control, cost reduction, and high production. So it provides a solution to large architectural projects. Last but not least, pre-stressed concrete is a rapid construction that we can save a lot of time that links to the cost. Apart from that, because pre-stressed concrete is prefabricated in the factory, it has better quality control that cast in situ concrete. There is also a definite savings stirrups since shear in post-tension concrete is reducing the inclination of the tendons and diagonal tension is further minimized due to the presence of pre-stress. And that's all from me. Thank you.